Hi, welcome to solveandgo.com. This video is the next video in a series of solutions to the Math 135 final exam from 2010. This question involves finding higher order derivatives, and we're going to need to find a pattern. So let me state the question for you. Let f to the power of n in brackets of a denote the nth derivative of the function f at a. So you take the derivative of f n times and you plug in a. If f of x is sine x cos 2x plus cos x sine 2x, then f to the power of 52 at pi over 18 equals what? Okay, so the 52 is a big number, especially if you're thinking about taking the derivative 52 times. So clearly, there's a trick. We're not required to take the derivative 52 times and then plug in the answer, or plug in pi over 18 in this case. What we need to do is find a pattern. So we're going to take the derivative of f, and hopefully the derivatives follow some pattern that we can easily repeat. So let's just start taking the derivative and see what we get. F prime of x is cos x cos 2x plus sine x times negative 2 sine 2x. So this is using the power rule, the product rule rather, on the first term here, plus negative sine x sine 2x, so like that, plus 2 cos x cos 2x. So try that for yourself. Take the derivative. This is what you should get. Pause the video if you need to. Okay, this isn't really showing us any pattern in the sense that we don't really, for instance, have a multiple of the function above or the function above exactly. So it looks like we're going to have to take the derivative at least once more to find some pattern. So let's go ahead and take this second derivative. Okay, so there's the first derivative. I'm just going to write down the second derivative. Things get a little complicated at this point, but you just need to be careful. So I'll show you what you should get, and you can try it on your own. Again, it's just applying the product rule and the chain rule carefully. What you get is negative sine x cos 2x minus 2 cos x sine 2x minus 2 cos x sine 2x minus 4 sine x cos 2x minus cos x sine 2x minus 2 sine x cos 2x minus 2 sine x cos 2x. Let me put this down the next line. Minus 2 sine x cos 2x. One more term, minus 4 cos x sine 2x. Okay, so these are the terms you get. The original function started off with 2 terms, both of which are products. Every time you use the product rule, you double the number of terms. We did that twice, so we should have 8 terms, which we do. Now the idea is to simplify this by collecting like terms. So for instance here we have sine x cos 2x, sine x cos 2x, and there should be one more sine x cos 2x right here. Okay? What are the other terms we have? We have cos x sine 2x, cos x, let me do this in a different color to be clearer. Okay. So those in red are all like terms. In green, we'll also underline like terms. So we have cos x sine 2x, cos x sine 2x, cos x sine 2x, and we need one more term. Let's see. So this should not be red, it should be green. Okay, this is what I mean by being careful. And here we have sine x cos 2x, which should be red. Okay, so we have 4 terms of cos x sine 2x and 4 terms of sine x cos 2x. Now what we do is we combine like terms and see what we get. So for sine x cos 2x, what do we have? Negative 1 minus 4 is negative 5. Minus 2 is negative 7, and minus another 2 is negative 9. Okay, and the same thing for cos x sine 2x. We have negative 2, minus 2 is negative 4, minus 1 is negative 5, minus 4 is going to be negative 9. So we get this, and now we start to see a pattern. So we have negative 9 times sine x cos 2x plus cos x sine 2x, which, as you'll notice, is negative 9 times f of x. So if we take the second derivative of f, we get negative 9 times f. So what would happen if we took, say, the fourth derivative? We want to realize what this pattern is going to be here. So say we wanted to take the fourth derivative.